Hi students. All waves, such as sound waves or light waves, returns back while they are crashing into any obstacle. So the reflection is this. Reflection is the bouncing of the waves from any surface. For example, when the sound waves are reflected from any surface, we call this process as echo of the sounds. So by using this technique, we are trying to find out, to determine the distance between the source of the sound and to the object. So this is called echolocation. But today I'm gonna try to explain you the reflection of light waves. So first of all, we need a mirrored surface, because it's better to have the reflection process while there is some mirrored surface. And we should talk about the normal of any surface. What is the normal? Normal of the surface means that the perpendicular line of any surface. So this mirrored surface is a horizontal surface, and this dashed line, spotted line, shows us the normal of the surface. Normal of the any surface is a perpendicular line that is descended to the surface. As you see here, we have right angle. And what's the rule of the reflection process? When the light beam comes to the point, let's say this point, let's call this point A, it reflects something like this. So the coming light beam is called incident light. This is incident ray or incident beam of the light, and the light that is reflected, it's called reflected ray. This one is reflected ray. And while we are talking about the angles of incidence or reflection, we take the angles from the light beams to the normals. So as you see here, we have incident ray, and this is the normal of the surface. And let's say this is theta 1. We take the angle from the ray to the normal, as you see. So theta 1 is angle of incidence. Angle of incidence. And let's take another angle and represent it by theta 2. So this angle is the angle of reflection. And as you see, we take the reflection angle from the reflected ray to the normal of the surface. So the theta 2 is angle of reflection. As you see, we take the angles from normal, all the angles. Incidence angle or reflection angle, it doesn't depend. All the time we take the angles from the normal of the surface. And the reflection rule is this. Incidence angle is always equal to the reflection angle. Theta 1 equals theta 2. That's a very simple rule. And now if you understand, let's go on an example, try to solve it. So here was sun. This is sun, a bright sun, and this is mirror. And the question is this: when the light beam comes from the sun like this, and the angle between the incident light to the normal is, to the surface, let's say it is 40 degrees. And first, find out angle of incidence. B, angle of reflection. And the angle between incident and the reflected rays. So let's try to solve it. Let's start with the A. Find out the angle of incidence. So here we see that the light beam creates 40 degree, but with the surface. But as we mentioned that the angle is taken from the normal of the surface. So first we should draw to this point a normal, which is perpendicular to the surface. So this one is our normal. All the time students try to draw the normal of the surface, and then it is easy to see the angle. So if it is 40 degrees, this one is 50 degrees, right? Because the normal creates 90 degrees. If we have 40 degrees here, then the angle of incidence is 50 degrees. So answer to the A is 50 degrees. And B, angle of reflection. We mentioned that angle of incidence equal to the angle of reflection. So we have the same value of the angle, 50 degrees. Let's try to demonstrate it. Reflected light is something like this. And if it is 50 degrees, then this one is also 50 degrees. This one is angle of reflection. And coming to the final one, angle between incident and reflected rays. Sometimes there are questions with something like this. Let's try to erase this one. And first of all, we should try to indicate the incident and reflected rays. This one is incident ray, and this one is reflected ray, right? And trying to find out the angle between them, it's very easy again, because this one is 40 degrees, this one is 50 degrees, and angle of incidence is equal to the reflected light, 50-50. So the total angle between reflected and incident lights is 100 degrees, students. Thank you for your attention.